Good afternoon, learners, and welcome to Dr. Diablo Vidyapit Center for Online Learning. I am your faculty, Professor Anand, for this course that is OMB AIML 303 and OMBBA 305, that is Performing Analytics with Python. Learners, in this session, I'm going to cover unit number 7 and unit number 8. So, unit number 7 is Analyzing Web Data. So, once we complete with 7, then we'll move forward to unit number 8. So before I could proceed in this session, please confirm that I am audible and my screen is very much visible to all of you guys. Please confirm in the chat box. Am I audible? Yeah, and my screen is visible as well, Mangesh? Yeah, so thank you. So let's start with the session, that is unit number 7, Analyzing Web Data. So in this session, I'm going to cover about introduction to data wrangling. What do you mean by data wrangling, and what are the tasks that are performed under data wrangling, like data cleaning, like data transformation, and string manipulation? And what are the tools which are used to perform all these tasks, that is cleaning of data, transforming of data, and string manipulation? Then we will learn about the emerging trends and challenges in data wrangling. So basically, when I refer data wrangling involves processing the data in various formats, like merging the data, grouping the data, concatenating the data, and transforming the data. So all these processes are referred under the umbrella term, that is data wrangling. So the purpose for the purpose of analyzing or getting them ready to be used. So what is the purpose of data wrangling? Of course, to make the data ready for the purpose of further analysis and getting them ready for extracting the insights. So Python has many built-in features to perform all these tasks, such as cleaning the data, merging, grouping, and concatenation. So we can apply all these wrangling methods to various data sets to achieve the analytical goal. So data wrangling is also called as data cleaning or data munging, that refers to the variety of processes designed to perform or designed to transform raw data into more readable and usable formats. So the purpose of data wrangling is to make your data ready for data analysis. And the exact methods differ from project to project depending on the data that you are using and the goal you are trying to achieve. But overall, when I say data wrangling, I am processing the data, I am making the data ready for data analysis, and in that data wrangling, I'm cleaning the data, I'm merging the data, I'm grouping the data, I'm transforming the data so that it can be brought from the raw data into more readable and used formats, so that I can apply the data analytics tools and methods in order to extract insights from that data. So before we build a model, before we extract insight from the data or data sets, we need to make that data set ready for data analysis. Means what? We need to clean the data. Means what? We need to find out if there are any missing values in the data set, if there are any duplicate values are there in my data set, if there are any anomalies are there in my data set, uh, uh, if there are empty cells in that data there, how I can fill those empty rows or empty columns. So all these things has to be performed before we are actually building the model, or before we actually writing the algorithm, or we try to predict, or we try to train or test our model on training and testing the data. So here this is very important stage, as this stage would impact on the overall predictions, overall insights that would be extracted from your model. So that's why we need to understand the various processes which are carried out in data wrangling. So what are the objectives of data wrangling? So the objective is to merge the multiple data sources into a single data set for analysis. So sometime we may require to extract the data, we may require to get the data and combine that data into a single data. Means what? Sometimes we may need the data from different data sources or data resources, and we need to convert those data that we have collected from different sources into a single data set. So that could be the one purpose of merging, that sometimes we need to combine, sometimes we need to merge multiple data sources into a single data set for analysis. Again, if you want to identify the gaps in the data, like I said that if there are any empty cells in your spreadsheet, if there are any mm, uh, uh, duplicate cells in your data set, if there are any anomalies in your data set, that you need to identify and that you need to handle, that you need to treat them. Say, for example, if there are missing values, then you need to treat those missing values either by deleting or by filling up with by using some methods like mean, mode, and median. So the objectives can be different, but these are the overall objectives that we normally perform the data wrangling in order to identify the gaps in our data set. So deleting data that's either unnecessary or irrelevant to the project that you're working on, again, can be the objective, so that we can delete the unnecessary features, unnecessary columns, irrelevant columns from our data set. But first we need to identify them. So identifying the extreme outliers in the data is also very important, as the outliers will impact on the accuracy, on the performance of your model. So identifying the outliers and deleting the outliers, either explaining the dependencies or removing them, so that analysis can take place. So these are also can be the objective for performing the data wrangling. So now what are the steps that are involved in data wrangling? So each data project, like I said, that requires a unique approach to ensure its final data set is readable and accessible and analyzable. That being said, several processes typically inform the approach, and these are the commonly referred to as data wrangling steps or activities. So every project requires a unique approach to ensure its final data set is ready. But having said that, there are several processes which are typically performed in all data projects. So let's look at them. What are those different steps? First one is the discovery, in which we discover the references to the process, so that we are familiarized uh, with the data, that you conceptualize how you might use it, or you can like it to looking in your data set. Like, say, for example, it's like looking it into a refrigerator before cooking a meal to see what ingredients that you have at your disposal. So first step could be the discovery, where we are understanding the characteristics of our data set, what we have at our disposal. So in discovery or during discovery, you may identify the trends or patterns in the data, along with the obvious issues such as the missing values, the incomplete values that need to be addressed. And this is an important step, as it will inform every activity that comes afterwards. So that will be the first one, that is discovery. Second one can be the structuring. Here, raw data is typically unusable in its raw state because it is either incomplete or misformatted for its intended application. So data structuring is the process of taking the raw data and transforming it into into more readily leveraged, and the form your data takes will depend on the analytical model that you are going to use it. So this is structuring. The next step is cleaning. This is the process of removing the inherent errors in the data that might distort your analysis or render it less valuable. Cleaning can come in different forms, including deleting the empty cells or rows or removing outliers and standardizing the input. And the goal of data cleaning is to ensure that there are no errors or as few as possible that could influence your final analysis. Also, if there are any errors in your data set, if there are missing cells, if there are duplicate values, if there are outliers in the data set, then that could definitely going to influence your final analysis. That is your final output. The fourth step could be enriching. So once you understand your existing data set and have transformed it into a more usable state, the second step could be the enriching, that you must determine whether you have all of the data necessary for this project at hand. If not, you may choose to enrich or augment your data set by incorporating the values from other data set. Means what? Here we perform feature engineering. Means what? If your data set does not have all the ingredients that you have, then what we do? We go to the external sources and we purchase some the data that you want. Say, for example, for preparing a dish, if in your refrigerator you don't have all the ingredients, then what you will do? You will go to the market and you will purchase those extra elements. So in the same way here, in enriching step, what we are doing here, we are understanding that I have everything at my disposal before going for data analysis. But if unfortunately, if you don't have the necessary data or necessary features or necessary columns in your data set, so in that case, you need to get those values and incorporate those values from other data sets or other resources. So for this reason, it is important to understand what other data is available for use. So this is called as enhancing your data set, that is enriching your data set. So here we are incorporating some data values externally so that my data set will be enhanced and enriched. The next step could be validating. So once the data is been, you have enhanced it, the next step in data wrangling is validating. So data validating refers to the process of verifying that your data is both. I think somebody is not on mute. Please mute yourself. This will disturb the others. So please mute yourself. So here I'm just explaining the steps of data wrangling, and after that I'm going to show you practically how we can use these data wrangling tools and methods to perform a practical example. How we can use it practically, I'm going to show that. But here first I'm giving you the steps of data wrangling, the common steps, the general steps of data wrangling. So the fifth step is validating. Here we are validating the data from the perspective that it is consistent and it is of high enough quality. And during validation, you may discover issues you need to resolve or conclude that your data is ready to be analyzed. So validation is typically achieved through various automated processes and requires some programming. So in validation, we are ensuring that my data is consistent and is of having high enough quality. And in order to validate a data, it can be done by using some automated processes and it requires some programming as well. So this is step number 5, that is validating. So if you decide that enrichment is necessary, you need to repeat the steps above for any new data. The next one is publishing. So once your data has been validated, you can publish it. And this involves making it available to others within your organization for analysis. The format you use to share the information, such as it can be in the form of a written report or it can be in the form of electronic file, will depend on your data and the organization's goal. So any analysis a business performs will ultimately be constrained by the data that informs them. So if data is incomplete, unreliable or faulty, then analysis will be the same. That is, it will diminish the value of any insights obtained if your data is incomplete, if your data is inconsistent, if it is unreliable. So data wrangling seeks to remove that risk by ensuring that data is in a reliable state before it could be analyzed and leveraged, that is used. And this makes it a critical part of the analytical process. So it is important that the data wrangling can be time consuming and taxing on resources, particularly when done manually. And this is why many organizations institute policies and best practices that could help the employees streamline the data cleanup process. For example, requiring that the data includes certain information or be in a specific format before it could be uploaded to the database. So for this reason, it is vital to understand the steps of data wrangling process and the negative outcomes associated with incorrect or faulty data. So from this point of view, data wrangling is very, very important. So now we'll move on to the practical aspect of how we can use these data wrangling steps practically by using a practical example. Here I'm going to share my screen that is of Google Colab. Please confirm in the chat box that whether it is visible to all of you. I'm going to share one more time. Yeah. So guys, is it visible? That is unit7.ipynb Google page. So first thing first. So first thing first here, like I said that I'm using the Google Colab, isn't it? So I'm using online. So here I need to have the data set at my disposal because I am executing the this program on by using the Google Colab that is online. So that's why I need to map my data set to this page. So here I have mapped my Google Drive in my Google page. So then I can use the data set. I have stored my data set. That is the data set that I'm going to use here. That is a Titanic.csv. And this Titanic.csv data set is available on Kaggle. So it is freely available on the internet. Just Google it. That is Titanic.csv. You will get the data set. So here I have stored that Titanic.csv dataset file, dataset onto my Google Drive. After that, here I have to connect, I have to map, I have to mount my Google Drive to this Google Colab page with the help of this command that is from google.colab import drive. So I have imported drive. After that, with the help of the mount function, I have actually mounted my Google Drive with the help of drive.mount. Specify the syntax of your Google Drive. That is absolute, the URL. This is absolute. So sorry, this is the relative URL. And after that, you need to execute this cell. So when you execute this cell, it will ask you to select the uh, email ID. Select the email ID that you are using that is associated with your Google Drive. And after that, it will ask you to give some permissions. So click on the allow button. Now you can see that the drive is already mounted because I have previously mounted it. So that's why if I try to mount it one more time, it is giving me the message that your drive is already mounted. So now after that, the next step is to import the necessary libraries. So here I have imported pandas, seaborn, and matplotlib. So pandas for performing the computations and seaborn and matplotlib for visually for visualization for graphics purpose. So here I have imported three libraries: pandas, seaborn, and matplotlib as PD, SNS, and PLT respectively. After that, I need to load that Titanic data set into my Google page. So here I've only mounted. So now here I am loading that data set. How to load? By using the pd.read_csv function, and to this read_csv function, we need to provide the absolute URL of your data set, that is starting with the content slash drive slash name of your Google Drive slash the actual data set name. So this will load the Titanic data set into the Titanic data frame. So this statement will load the Titanic.csv file into my Titanic data frame. After that, I need to perform some data exploration activities like I want to find out the characteristics of my data. I want to understand my data set. What are the ingredients? What are the columns present in my data set? So for that, I can call the function that is titanic.info. So info is the function of the data frame. So when I say Titanic is the data set name. So Titanic.info will give me the information about the features, about the column names, about their data type in my Titanic.csv file. After that, I want to know the statistical summary of my data set, and that can be achieved with the help of describe function. You have to call the describe function on the uh, Titanic data set, that is data frame. Titanic dot describe will give you the statistical summary like mean, mode, standard deviation, that is quarter one, Q1, Q2, and Q3 values of your data set. So these two functions will give you the details about your data set so that you can understand your data set thoroughly. What ingredients you have at your disposal, isn't it? What are the characteristics of your data set? After that, I want to see the first 5 records of my data set. So for that, I called upon the function that is head. Titanic.head will display the first 5 records of the data set of the data frame, that is Titanic.csv. After that, I want to find the missing values. There are any missing values in my data set? How to find the missing values? By calling the function that is fill NA. So here I'm handling the missing values. So for example, filling missing age values with the mean age. So here I am finding out the missing values with the help of fill NA. If there are any missing values in the age column, in the age, feature. So in that case, that empty age will be filled with the mean value of my data set. So before that, I would like to show you the data set of the Titanic so that you can understand what are the different columns in that data set. Give me a minute. I will open that data set in this session. That is Titanic.csv. It is opening. Yeah. Can you see the data set? Guys, is it visible data set?
Yes, sir.
Yeah. See that these are the columns. Basically, it is a Titanic data set which will give you the list of passengers with their age, with their with their gender, with whether they are survived or not. So this is a data set about the Titanic passengers who have traveled with that ship. So here I'm using that data set. As you can see the features here, survived, name, sex, age, SIBS, PArch, ticket, fare. So these are the different columns, different features which are present in that Titanic data set. So it is available on the internet. Just you need to Google it. It is available on Kaggle website. So yeah. So here, if there are any missing values in the age column, isn't it? So I want to fill that missing value for that particular age column for that particular row. I want to fill that missing value with the mean of my data set, isn't it? See that I could have deleted that row which has the age column null. But if I could delete that row, then the predictions that I would make from that data set, it would not be the correct, isn't it? So that's why you have to decide whether what you want to do, how you want to treat the missing values, whether you want to fill the missing values by using some strategy. Like here, I have used the strategy like I want to fill the missing values with the mean values. But another strategy could be that I could delete that empty that row which contains some missing values. So it depends on the application. It depends on your strategy, how you want to treat the missing values. But here I want to treat the missing values. I want to fill the missing values with the mean of my data set. So that's why here I have used that Titanic. I want to find out the missing values of the age column. So here I'm giving age dot fill NA is the function. If there are any missing values in the age column, I'm finding out first with the help of fill NA. After that, if there are any, then I'm filling that value with dot mean, comma, in place is equal to true. So in place is equal to true means what? It is immediately updated into the data set, isn't it? So that is the meaning of in place is equal to true. So here I am printing the missing values total. After doing that, after filling the missing values, still I want to check whether there are any other missing values and what is their total number of values. So this is how here I have treated the missing values with the help of dot fill NA, and with the help of dot mean, I have filled those missing values in the column age with the mean of my data set, the same column that is of age. So this is the strategy that I have applied here for uh, filling up the missing values. Second, the next step could be handling the duplicate data. But here there is no duplicate row. So that's why it is not applicable in this case as the Titanic data set is clean. So it depends, like I said, that it depends on your data set. If your data set does not contain missing values, then you don't need to perform this step, isn't it? If your data set does not contain the duplicate values, again, you don't need to perform, you don't need to check for handling the duplicate data. So it's not necessary. If your data is clean already, then you don't need to again find out the missing values or the duplicate values. As in this case, the Titanic data set is already clean. It is clean in the sense that it does not contain duplicate rows. So that's why I don't need to find out, I don't need to handle duplicate data here. Now, data transformation means what? If there are any categorical columns, if there are any categorical values. So for example, in that data set, if I see the data set, does it have any categorical value? I have to check it. But here I have already executed this example. Otherwise, you could have seen here for male as for gender as, yeah, you can see here. Still, you can see here sex is male, female, male, female, male, female. So here I want to convert these categorical values into numerical values, isn't it? So here I want to convert male is equal to 0 or female is equal to 1. So here I have to perform, or I have to transform the categorical values into a numerical values. So here I will perform the what you can say uh, I need to convert the categorical values into a numerical one. So here uh, converting sex column, that is to numerical values, 0 for female and 1 for male. How to perform, how to transform the categorical values into numerical values, that is with the help of mapping function. So here Titanic sex is the column, is equal to Titanic sex dot map with female as 0 and male as 1. So now when you execute this statement, the data that you could see here for sex for male as 1 and female as 0. So I require the age column as numeric one. So that's why here I am specifically transforming these categorical values, that is male, female, to numbers, so that I can perform some computation, I can perform data analysis, I can apply data analysis methods on the age column, isn't it? So that's why here I'm transforming the categorical values like sex, that is male and female, female as 0 and male as 1. So after that, here I want to see the result. So for that, I have called upon the function that is Titanic.head, so that first 5 lines, first 5 records will get displayed. So now the next step could be enriching the data, enhancing the data. How we could enhance? Like I said, that if you don't have the ingredients, if you don't have the features, if you don't have a data or a column in your data set, what you do? You have to take that data from externally, or else here, in this case, what I'm doing here, I'm combining, I'm creating a third column from the two columns. So in this way also it is possible. Sometimes it is not always that you have to get the data externally. Even you can create a new column, a new feature from the existing column, isn't it? So that also be possible. That also be called as enhancement or enrichment. So here we are creating a new column with the name family size by combining SIB, SP and PARCH. So there are two columns. If you could see in the data set, that is PARCH and SIBS. So here I'm combining these two columns and creating a third column that is with the name that is family size, isn't it? So here I'm enriching, I'm enhancing my data set by adding some column. Uh, Here I am creating the new column by combining the existing two columns. So that is also possible. That is also called as enhancement or enrichment. After that, again, I want to see now how my data looks like. So for that, again, I have called the Titanic.head function. And again, the next step could be handling the outliers. Again, this data set, the outliers is not applicable to this data set, as the data is assumed that data is relatively clean. So again, I assume that there is no outliers in these data sets. So that's why the handling of outliers is also not applicable to this data set. Now, the next step could be that is a data visualization, that is visualizing the data using the heat map to identify the correlations. So how we do that? By using the object that is sns.heatmap, providing the titanic.corr function, comma, annotate is equal to true, cmap is equal to cool warm. And after that, I have to call the show function on the PLT, that is matplotlib object so that I can visualize the correlation coefficient of my data set. So now I have explained all these lines one by one. Now we will execute all these things, all these statements one by one. So here I will execute first the info part, the describe part, and the head part. Okay. And all other part, I will just comment it. Okay. So I execute. Now I can see the information part. Can you see on the screen, guys? Is it visible? Yeah.
Yes, sir.
You can see the column names. That is passenger ID, survived, P class, name, sex, age, SIB, SP, PARCH, ticket, fare, cabin, and embarked. So this is the output of info function. That is the output of info function. Then the output of describe will give you the statistical summary of your data set in the sense of count, mean, standard deviation, mean, that is 25%, 50%, 70%, and maximum value. So this is the output of describe. Then I have displayed the first 5 lines, first 5 records of my data set with the help of head. Now you can see the first 5 lines or first 5 records of the data set, that is Titanic.csv. Since it is not been displayed here, so that's why it is continued on to the next line. So the remaining columns are displayed on the next line, isn't it? So this is the output of dot head. As you can see, the first 5 lines. So this is the output of head. Then I will close this output so that next time because the output screen is very small in size, so that's why here I'm hiding it. Now I'm filling the missing age with the mean age, and now I will print the missing values information. So I will execute this. So now printing missing values of Titanic.sum. Yeah, missing values of the Titanic sum. As you can see that passenger ID, survived, P class, name, sex, age, SIB, SP, PARCH, ticket don't have missing values, but the cabin and embarked have some missing values. But for my data analysis, I don't require cabin and embarked values. So that's why I have not treated the missing values of the particular column, that is cabin and embarked, isn't it? See that we need to understand what columns data that you require, what is relevant, what is irrelevant, isn't it? What is irrelevant, you can just delete them or we can just ignore it. So here, even the cabin and embarked is having empty values, but here I have not treated them because I don't need them. So that's why I have just ignored them. So after that, after treating the missing values for age, now here I want to convert, that is categorical value sex, male is equal to 1 and female is equal to 0, so that I can categorize, I can convert into numeric 1. So here I will display after executing this code. So here I'm executing it. After that, again, here I'm displaying the first 5 lines. So after that, you can see the sex as this one is male, Broad M. Owen Harris. Again, if you want to compare, you just can execute the above statement one more time. So you can see that the sex column that is converted into numerical 1, that is 1 for male and 0 for female, isn't it? So here I have performed data transformation. After that, I want to, there is no outliers, consider that. After that here, I want to print, I want to visualize my data set by using the correlation coefficient with the help of the heat map. So now I will execute that. So after that, you can see the correlation coefficient heat map. So now how to interpret this? How to interpret this correlation map? So here I would like to interpret the entire example one more time, means what we have done in this example and how we have to interpret that correlation coefficient matrix. So here in this example, we have handled the missing values by filling the missing age values with the mean age, isn't it? And we have transformed the sex column into numerical values. And then we have enriched the data set by creating a new column with the name family underscore size based on the number of based on the number of siblings slash spouses and parents slash children's. So here we have created family underscore size by combining two columns, and then we have explored the data by visualizing the correlation between the numerical features using a heat map. So here in this example, provided with the Titanic data set, the heat map is used to visualize the correlation matrix between numerical features in the data set. So each cell in the heat map represents the correlation coefficient between two variables. The correlation coefficient ranges from -1 to 1 that you can see in the diagram, where wherever you see 1, it means perfect positive correlation. As one variable increases, the other also increases. Wherever see you the value as 1. If you see the value as 0, it means that there is no relation or no correlation. But if you see the value as -1, it means that perfect negative correlation. As one variable increases, the other variable decreases. So here, how to interpret the color intensity. So if the darker color, the darker color you see, that that represents the stronger correlation, while the lighter color represents a weaker correlation. So in that way, we have to interpret. If you see a dark color, then it represents stronger correlation. And if you see a lighter colors, it represents a weaker or low correlation. A positive correlation are typically displayed in shades of blue, while the negative correlations are displayed in the shades of red. And how to represent the specific values? The actual correlation coefficient are often annotated in each cell, and these values provide a numerical representation of the strength and direction of the correlation, of the direction, sorry, of the direction of the correlation. So look for the strong positive or negative correlation between variables. So for example, if you observe a dark blue cell between survived and fair, it indicates that the higher fair values are positively correlated with the survival. So in this example, you might expect to see a strong negative correlation between sex and survived. But if the data set is coded such that the female is represented by 0 and male is represented by 1, this would mean that being female, that is coded as 0, is correlated with a higher chance of survival as coded as 1. So we have used the heat map to identify the potential relationship between the variables. So for example, if you notice a strong correlation between two features, it might suggest that they are related and changes in one might affect the other. So we have observed a strong correlation between the P class, that is passenger class, and fare, as you can see in the picture, in the diagram of heat map. So there is a stronger correlation between the P class, that is the passenger class, and the fare, of course. So this would make sense since higher passenger classes are likely associated with higher fare. So that you can see in the heat map. If the passenger class is higher, then definitely the fare class is higher. So it means that the higher passenger class are likely associated with higher class, higher fares. So here you can interpret a specific cell in the heat map, that is the correlation coefficient between variable x, between variable A and between variable B is x, indicating a positive slash negative correlation. So keep in mind that the correlation does not imply the causation, and further analysis or domain knowledge. Domain knowledge may be required to understand the underlying relation between the variables. So this is all about this uh, chapter number 7, that is data wrangling. So I hope that you have understood the every step of data wrangling that I have explained. So now, before I would move on to the next concept in this class, I would like to give the feedback link for this session so that you guys give your feedback by filling this Google form. Here I am giving the link, and I hope that it is visible to all of you. So here I've given the link for feedback. So here we have completed the chapter number 7. Now we move on to the chapter number 8. Give me a moment. Yeah. I think my screen is visible to all of you. That is chapter number 8, data analytics part 1. Is it visible?
Yes, sir.
Yeah. So give me a moment. We'll take a break of 1 minute, and then after that I will resume. So give me a minute. We'll take a minute break and then we'll resume. Okay. So now we'll start with unit number 8, that is data analytics part 1. And learners, in this session, the topics are, for example, analytic process model, analytics model requirement, types of data sources, sampling, and types of data elements, data visualization, visual data exploration, and exploratory statistical analysis, and handling missing values and outlier treatment. So if you see the content of this unit, the first 3 to 4 topics that we have already covered in the last units or so. So here I am going to focus mainly on visual data exploration and exploratory statistical analysis. So this is where I'm going to focus more on, and on this topic, I'm going to execute the examples. So here I'm going to focus on visual data exploration and exploratory statistical analysis. All other things that are covered in the previous units, some or other. So here we'll start with the analytics. So basically, what is analytics? The analytics is a science of applying statistical methods to our data sets so that we can extract valuable insights from the data, and that could help us to solve complex business problem, and that could help us to take a better business decision. So when I say data analytics, it means that I'm applying statistical techniques. I'm applying the statistical techniques, mathematical methods to my data set so that I can extract some meaningful insights that will help me to solve the business problem, or that would help me in taking a better informed decision. So straight away, we'll move on to the exploratory part. So all these things that you can see that it has been already there in Swayam. It is just explanatory. All these things are theoretical part, that is introduction to data analytics, understanding the analytic process model, or what things that you need, what that you require to understand. It is primarily a template that defines the key phases of data analytic process, from defining a business problem to its solution. It guides the organization to follow when to conduct data-driven projects. So just these are all theoretical part. Just you will go through it. You will understand what are the different stages of analytical process model. That is defining the business problem definition, then collect the data and prepare the data, then go for data exploration and visualization, then data modeling and analysis, then deployment and monitoring, and then importance of each of these steps. So here all these things are being given in the PPT. Just go through the PPT. The PPT is available on SWAYAM as well. So here I will focus mainly on the visual data exploration, isn't it? All these things that I have already covered. So for example, data modeling and analysis. I have covered this part in the last some of the units of this subject, and I have practically demonstrated how to build the model, and how we can able to how we can train our our machine learning algorithm on the training data, and how we can test the built that the model that I have built on the training, so that I can compare the results of testing data and training data. Then I can understand how well my model has learned, what is the accuracy level of my model, and how we have checked the accuracy level by, for example, we have used that is mean absolute error matrix. By using that, we have compared the values of tested and trained output, so that we can ascertain that how well my model has learned, what is the accuracy level of my model in the previous units of the same subject. So I will not repeat that. So I will just move on to the practical aspect, so that it would be helpful for you also to understand practically, and as you people require more practicals. So from that point of view, here my focus is on giving you the more practical exposure. I hope you understand that. So first thing first, we need to mount the Google Drive. So here I have mounted my Google Drive with the help of drive.mount. Specify the name of your drive. After that, we need to import the necessary libraries, including the pandas for data manipulation, scikit-learn for machine learning tasks, and category underscore encoders for WOE, that is weight encoders. And I have imported the necessary libraries. So here we have to import the necessary libraries. So for example, pandas for data manipulation, and scikit-learn for machine learning task, and category underscore encoders for weights of evidence. That we will, I will discuss, I will explain that what is that weight of evidence, what is used for that. So here I hope the screen is visible. Yeah. Is it visible, guys? Unit8.ipynb. Is it visible? Am I audible?
Yes, sir.
And it is visible?
Yeah.
Unit8.ipynb.
Yes.
So first we have mounted the Google Drive, then we have imported the necessary libraries. After that, we have loaded the data set. So again, here I have used the data set, that is credit-data.csv. And again, this data set is available on Kaggle as well. So all the data sets, more or less, they are available on the Kaggle website. You just need to Google it. You will find the data set on Kaggle or any other website. So here I have used the credit_data.csv. And this data set, okay, I will I will show you the details of the credit.csv file. Give me a moment. Yeah. So this is my credit.csv file. Is it opening? Yeah, it's opening. Yeah. Can you see the data set? Credit_data.csv. Is it visible, guys?
Yes, sir.
So you can see that this data contains the information about the customers. So here I'm going to check out the credit worthiness, the default, whether that customer is going to default or not. I'm going to predict an event, that is whether the customer or whether the person who gets this credit, whether is going to pay the amount or is going to default it. So using this data set, I'm going to predict some predictions about the future outcome. So this is my data set that I'm going to use here. And here in this example, so here I have loaded that data credit_data.csv file. Now, all things that you want to do here, you can perform, you can call the data.info, you can call the data.describe in order to understand the elements of your data. So here I have loaded the data in credit_data. So now this is my data frame. So this is my data frame, which contains credit_data.csv. So now here I'm performing the data pre-processing, that is standardizing the numerical features like the credit amount and age to have a mean of 0 and a standard deviation of 1. So here I'm standardizing the data, that is credit_amount and age, by using the scalar object. And here I have imported the standard scalar from sklearn.preprocessing. I have imported the library called as standard scalar, so that I want to bring the values of credit_amount and age to have a mean of 0 and a standard deviation of 1. In order to bring the data, in order to standardize data, I have used the standard scalar object. So here I need to create the object of standard scalar with the name scalar. I have created here. And after that, I have applied that scalar to the credit_amount and the age as well. So here, as you can see, numerical features contains, that is credit underscore amount and age. And for this, I want to apply this scalar function. So credit underscore data, that is numerical features, which contains credit underscore amount and age is equal to scalar dot fit underscore transform credit dash data, that is numerical features, that is credit amount and age. So these both fields now have the mean of 0 and a standard deviation of 1. Means what? These two columns are now being standardized numerically. So here I have performed data pre-processing. That is, I have standardized the data. That is age and check credit underscore amount. Now, after that, I am finding out the weights of evidence. So now, what is this weights of evidence? Let's have some information about this weights of evidence. So here, when I say the weights of evidence, that is WOE, the WOE is a statistical measure that is used in various fields such as finance, insurance, or data science. That is, weights of evidence is a statistical measure which is used in many domains such as finance, insurance, and data science as well. And it is often employed in the context of a binary classification problem where the goal is to predict the probability of an event occurring, such as defaulting on a loan or responding to a market campaign. So the objective of this WOE is to predict the probability of an future event, such as whether a person can default to a loan or responding to a market campaign or not. So here we are using the WOE, that is weights of evidence, for predicting for the probability of an future event. And WOE is particularly popular in credit scoring and risk modeling. We can predict whether a person can default on to loan or not, whether a person churn out or not, whether an employee will work for next 5 years or not. So for such probability, for predicting the probability of such an event, we can use the weights of evidence. So weights of evidence is particularly popular in credit scoring and risk analysis or risk modeling. It assesses the strength of the relationship between the predictor, that is the independent variable, and a binary target variable, that is dependent variable. So the WOE, that is weights, that is weights of evidence, is used to assess the strength of the relation. What is the strength of relation between dependent variable and independent variable by measuring the evidence for and against an event. So how it will do? By measuring the evidence for and against an event. What could be the event? Default, whether that person can be default or not, whether a person can churn out or not. So that is the event. So this against this event, it will measure the evidence. And from that, it can find out whether the relation between dependent variable and independent variable is strong or weak. So it is commonly used in the process of binding or discretizing the continuous variables. So in a sense that the weights of evidence is a statistical measure which is used in many domains, and it is often employed in the context of binary classification problem. And the objective of this is to predict the probability of an future event. That is the probability of an event occurring. So that is the use of weights of evidence. So here I am using the weights of evidence for this purpose, whether the person can default or not. So here I'm using the first I need to so here we are using the category underscore encoders from WOE. So you can see that here from category underscore encoders, I have imported, from WOE encoder, that is weights of evidence encoder, I have imported the category underscore encoders. So what this will do, the category underscore encoders library is used to perform the weights of evidence, that is WOE. It is used to perform the weights of evidence and encoding on the account underscore check underscore status column and the weights of evidence coding. So assume that the account underscore check underscore status is a categorical variable. So if it is categorical variable, we need to convert it. So here by using the weights of encoder, I have created the object of weights of encoder in the form of encoder. And after that, I am applying on to the account underscore check underscore status underscore WOE is equal to encoder dot fit underscore transform credit underscore data, that is my data set. I'm applying to the account underscore check underscore status comma credit data, that is default. So here I applied the uh, encoder, that is WOE encoder. Now I am selecting the variables, that is selecting the features, that is credit underscore amount, age, account underscore check underscore status underscore WE and default for modeling. So I assume that the credit underscore amount, age, amount underscore check underscore status underscore WE and default are selected features. So here I assume that all these features are selected. Now selected underscore features is equal to, I am selecting all these features and I am performing the selected features is equal to credit underscore data selected features. So now in a selected data, I have all these features. Now I am training my data. First, I am training my data, then I will test it. So for that, first I need to divide the data into testing and training. So basic commonly 80% of data is divided for training and 20% of data is divided, it is given for testing. So here I have built the model. Now I want to first thing that I have to split the data into testing and training. So how I do that? With the help of the function that is train underscore test underscore split selected underscore data drop. So here I am specifying the data for my training and for my testing. So as you can see that test size is equal to 0.2 means what? 20% for testing and 80% for training. So here I will get x dot train and y dot train is equal to 80% and x dot test and y dot test, that is x underscore test or y underscore text, that is test, contains 20%. So here I have splitted the data. After that, I am building the model, that is logistic regression model using the
Betul,
training
sir.
data. So model is equal to logistic regression.
Yes, sir.
I am creating the object of logistic regression with the name that is model. And after that, I am training my model on, as you can see, on training data, that is model dot fit x underscore train, comma y underscore train. So here I am training my model with 80% of data that I have splitted here. So once the model is being trained, now I can make predictions on the test set and evaluate the model's accuracy. So here I am testing the model's evaluation. That is how well my model has learned with the help of accuracy underscore score. That is a matrix, that is one matrix that we can use. And if you could remember in the previous example, we have used the MAE, that is mean absolute error, as a matrix in order to find out the performance of our model, how well my model has learned. But here I'm using another matrix that is accuracy, or also we can use F1 score as well. So here I'm using accuracy, that is accuracy underscore score, and here I'm comparing the Y test and Y pred. So where is Y pred? Here. Here I have got the predictions on testing data. So here you can see I have trained the data on the training data. I have trained my model dot fit x comma x underscore train comma y underscore train. Here I have trained my model. Once the model has been trained on 80% of my data, now here I am uh, testing my model, how well my model has been trained with the help of model dot predict. So here I am getting the model work on the testing data. So whatever the result, that result will be stored as y underscore pred. So it means what? Here I have predictions for unseen data, isn't it? This is unseen data. This is seen data, isn't it? The model knows this data because I have trained it on 80%. But here the model does not know this data. That is 20% of data. That is testing data. So here I have provided the testing data in order to make predictions for unseen data, and that predictions are stored in y underscore pred. After that, here with the help of accuracy underscore score function, I am comparing the result of, that is the result of y underscore test and uh, y underscore pred. So this is the result of testing, and this is the result of training, that is predictions. So predictions are compared with the actual result, and after that I will find out the difference between the how well my model has learned with the help of print accuracy. So what is the accuracy level of my predictions? How close my model is with the test results, that I can find, with the help of accuracy underscore score. So here two results are compared, and here I will check what is the accuracy level. I will, when I compare the result of testing and result of training, the accuracy underscore score function will give me the accuracy, how well my model has learned in the form of accuracy, that I can show here. So if I execute this example, you can see the accuracy result as say 0.735. So this is the result of 0.735. So what I can say here, how I can interpret here? So here I can interpret the accuracy of 0.735, that is 73.5%, means that the model correctly predicted the target variable, that is default or non-default, for approximately 73.5% of the samples in the test set. So I can say that my model has correctly predicted 73.5%. That is, it has correctly predicted the target variable. What is the target variable? That is default or non-default for approximately 73.5% of the samples. So for approximately 73.5% of the samples, my model has correctly predicted the target variable, that whether that 73.5% samples, whether they default or they not default for the loan that they have taken. So I can consider that 73.5% is good. So now I can say that my model has been well trained because it is correct 73.5 times. It is correct for 73.5% of my sample data. So I can say that my model has learned correctly. So here the positive aspect is the model is correct about 73.5% of the time, which might be considered a decent depending on the context. So I can consider that this is a decent performance considering the context, isn't it? But however, accuracy alone might not be if sufficient, especially if your data set is imbalanced or if false positive or negatives have different implications. For instance, in a credit scoring, where predicting the defaults accurately is crucial, you may need to consider metrics like precision, recall, or F1 score as well. So considering that accuracy is one metrics, but not only accuracy will give you the correct information, especially when you are predicting the defaults in credit scoring or in credit. So in that case, it is very necessary that you may also need to consider other metrics like precision, recall, F1 score as well. So if accuracy needs improvement, so on the other hand, if you only need the accuracy and if you need more improvement on the accuracy part, if you want to have more comprehensive evaluation, consider analyzing other metrics or exploring the potential enhancement to your model, such as hyperparameter, hyperparametric tuning, or using different algorithms. So that also can be used to improve the performance of the model if accuracy is the only thing that you are concerned with. So the interpretation of the accuracy depends on the specific goals and requirement of your project. So I hope that you understood the total concept. And again, one more thing is that I need to mention this, especially this one, the WOE encoder is not automatically installed in this Google Colab. We need to install it separately by writing the code like this in a cell, that is pip install category underscore encoders. Then only this example will get executed. Otherwise, it will not get executed as the category underscore encoders is not automatically installed. We need to install by using the pip command in a different cell, like here, like this. So with this command, we need to install the category underscore encoder. Then only we can able to execute this example. So in this session, I have covered unit number 7 and unit number 8. So before I conclude this session, I request you to please give your feedback by filling the feedback. The link of the same now I have given in this chat box as well. So this is the feedback link I have given here. Yeah. Kindly share the Google Colab link for the project. Thanks in advance. Solomon, please send me hi to my email ID so that I can share the Google Drive link. Yeah. Hello, Professor. The link you shared is asking for permission. See error message. You need permission. This form can only be viewed by users of the owners. Okay, just click on the send request for permission. Solomon. If it is asking for the permission, then click on the request permission so that I can allow the permission. Okay, even if it is not, it is asking for permission one more time. I would like to share all the Google Collabs, but you just need to send your email ID. Just say hi to my email ID so that I can share all the Google Collabs page. Yeah. So thank you all for joining this session. I hope you understood the concepts that I have explained here. First, I've explained theoretically, then I've explained practically as well. So before I conclude here, please give your feedback by filling the feedback form. So thank you everyone for joining this session. See you in the next class. Until then, have a great day ahead.